Namaste everyone, how are you all? I hope everything is fine out there. I am Ranjan Dhakar. Welcome back all of you to the Distance Learning Center of Best Montessori Elementary School. In the science of class 9, today I am going to start a new topic, that is solubility. Mixer and solubility. Okay, now first of all, before moving on to the topic solubility, here I have some of the terms that are really helpful in the chapter, in the topic, and these are mostly used in the higher level too. Now first we have to know what is the mixer. Now mixer, whenever two or more substances they come together, they are brought together, then that new substance is termed to be a mixer. Two types. These all we have been studying in the junior classes too. That's why I am not giving more focus on these terms. Heterogeneous and homogeneous, where the components of the mixer can be seen through our naked eyes, and if it cannot be seen through our naked eye, then that is a homogeneous mixer. Now the homogeneous mixer, they also makes solutions. Now solutions in terms of concentration. In terms of concentration, it is of two types. The first one is dilute and the second one is concentrated. Okay. Now solution itself means when solute gets dissolved in solvent, then there is a formation of solutions. Okay. The solid particle that gets mixed up is known as solute, and the liquid in which the solute is dissolved, that is called solvent. And we can say altogether solute and solvent, they mix up together, they sum up together to form a solution. If the amount of solute is less, then the solution formed is dilute solution. If the amount of solute is higher, more, then it is termed as an concentrated solution. That is in the terms of concentration of solute. Furthermore, solutions, they are of other three types also. Okay, the first one is saturated, and the second one is unsaturated, and the third one is supersaturated. Okay, now first let's move to unsaturated. That means the solution which can dissolve more amount of solute. Let me repeat again. The solution which can dissolve more amount of solute, that is called unsaturated solution. Now again, if we go on adding solute to the unsaturated solution, there comes a point at which the solution, it doesn't start to dissolve the solute. That type of solution is called saturated solution. We can define it as the solution which does not dissolve any solute. That means it doesn't dissolve, it doesn't mix any solute. Saturated, which can mix more solute, which can dissolve more solute. Unsaturated. Now, when we heat a saturated solution, then the solubility, the ability to dissolve, solubility. Okay, we will discuss more about solubility in next class. The solubility of the solution increases. That means the temperature has a direct proportion to the solubility. Now we know that saturated solution cannot dissolve any more amount of solute. But when we heat this, it can dissolve more amount of solute. And after mixing of more amount of solute, that solution is called supersaturated solution. The solution obtained after heating saturated solution. The solution obtained after heating saturated solution can be termed as supersaturated solution. And to obtain the crystal, for the crystallization process, the solution must be supersaturated. I guess all these we have learned in year 8 also. Now let me focus on the three different types of solutions. Actually, solution, suspension and colloid. These three types on the basis of size and different property. Size of what? Solute. Okay. Here the size of solute is less than 10 to the power minus 8 centimeter. Actually, it's average 10 to the power minus 8 centimeter. If the size of solid particles dissolved is around in the average of 10 to the power minus 8 centimeter. In suspension, if it is more than 10 to the power 5 centimeter, that means solid particles are greater here. And colloid means intermediate. Remember one thing, that colloid is the intermediate of solution and suspension. So, colloid is the intermediate of solution and suspension. Regarding solution, we have studied everything here. Homogeneous. Suspension is heterogeneous. Whereas colloid is heterogeneous. Though we think or it seems it is a homogeneous, but colloids are heterogeneous mixture. Okay, solutions are stable, suspension unstable, and colloids are unstable too. Colloids are stable. Now, this solution that does not, when we pass a beam of light, it doesn't scatter. Suspension, it scatters a beam of light, and colloid, it also doesn't scatters the beam of light. If we pass a ray beams of light through solution, it doesn't scatter the light rays. Suspension, it scatters, whereas the colloid doesn't scatters. And we are clear about the size. Now, solid particles cannot be seen by our naked eye. That means in solution we cannot see. In a solution of salt and water, can we see the salt mixed? No. Whereas in suspension, we can see by our naked eye. Let's take an example. We can see the particles of smoke. We can see the mud is soiled in water. That means through our naked eye, we can see the mixed solid particles. These are examples. Now, colloid, here solid particles again cannot be seen by our naked eye. Though colloids are heterogeneous. It is an exception. Colloids are the exception for heterogeneous, where we cannot see the dissolved solute or solid particles. We have been studying that heterogeneous are the types of mixture where we can see the dissolved particles. But colloids are those type of heterogeneous mixture where we cannot see the solid particles by our naked eye. Okay, and their size is 10 to the power minus 7 to 10 to the power minus 5. Example is, though we say only milk, whenever we see this milk by ultra microscope, a type of microscope, ultra microscope, then we can see the fats floating in the milk. Look, that means cannot be seen through our naked eyes, and this is the milk itself is an example of heterogeneous mixture. Being specific, we can say milk is an example of colloid. Okay, now let me talk about one more thing, that is how does the salt dissolves in water. How salt dissolves in water. Actually, for this we have to know intermolecular force. Intermolecular force. What happens is, whenever the salt is in its pure state, then this intermolecular force, the force is very high. That means one molecule is attracted towards the another molecules. Okay, one molecule is attracted towards the another molecules and goes on with a very strong force. But whenever take a spoon of salt and keep it inside the water, then that strong molecular force is broken up by the water, and that strong force, it becomes weak. Now the molecules of salt, they start to separate with each other. Since after mixing, after dissolving in the water, the intermolecular force becomes weak, and then molecule slowly starts dissolving in water. We can say, when we keep salt in the water, the strong molecular force between the molecules of the salt does no longer exist. The intermolecular force becomes weaker. With weak intermolecular force, those salt molecules get mixed in the water. Okay, this much for today. In this session we discussed about mixture, different types of mixture, and being specific we can say solution, suspension and colloids, types of solutions, dilute, concentrated, saturated, unsaturated and supersaturated solutions. Okay, in the next class I'll be continuing the chapter. I'll continue the chapter with solubility and what are the factors that affects the solubility of a substance, what is the solubility curve and all. Till we meet again, I hope everyone stay safe at home. Take care, bye bye, have a good time ahead.